Hi, my name is Sammy.
My name is Rita.
And my name's Teo.
And today we're going to be demonstrating the idea of conservative and non-conservative energy transfer and work using this roller coaster apparatus that we created. If we neglect any air resistance and assume that the surface on the inside of the toilet paper is uniform, then we can solve for the difference between the potential and kinetic energy. This difference in energy will be attributed to the energy loss due to friction. Here we're going to drop a marble at rest at the top of this incline. At this point in time, there is only potential energy present, and this can be found using the equation PE equals mgh. Now, when we drop the ball, it will gain velocity due to the force of gravity acting on the ball. As taught in class, the initial energy of the system is always equal to the final energy. So we know that the potential energy at the beginning will be equal to the potential energy at the bottom, plus the kinetic energy, because the ball will be moving at some velocity. And we have to take the frictional energy loss into consideration too.
So we have a ruler here to measure the distance of the marble after it rolls out, and we also have a stopwatch here to measure the time so we can calculate the velocity of this.
So here we have our free body diagram for our situation. We have our ball right here, and there is a normal force acting upwards perpendicular to the surface. We have our gravitational force that goes straight downwards with an x component and a y component, and our kinetic frictional force acting backwards. And the reason why our ball is accelerating downwards is because of this x component of the gravitational force that is larger than the frictional force, so it accelerates downwards through the surface.
So we'll be calculating the initial gravitational potential energy. So we have our mass, 2 grams, which is 0.002 kilograms. The acceleration of gravity, 9.81 meter per second squared. And we have our height, 0.3 meters, and this equals to
5.88 times 10 to the minus 3.
and that's our gravitational potential energy initially.
So since our initial energy is equal to the final energy, the output the potential energy at the beginning will be equal to the potential energy at point B plus the kinetic energy at point B and the work due to friction from sliding across this surface, which is the toilet paper roll. So we know that that will be equal to mgh at the bottom time plus 1/2 mv squared, which is the kinetic energy equation, and the work. So we know that at this point, we're going to make height 0. So we're going to have 0 potential energy, and we're going to have a certain velocity, but we don't have that velocity just yet, so we're going to calculate it. And we know that velocity is change in x over change in t, so it's just going to be 0.3 meters over 0.2 seconds, which is 1.5 meters per second. So subbing this into our kinetic energy equation, we get 1/2 0.002 times 1.5 squared, which equals
2.25 times 10 to the negative 3.
2.25 times 10 to the minus 3 joules. So obviously this is not equal to this value here. So we know that there's some energy loss that occurred, and we know that this is due to the force of friction acting on the ball. So we can solve this by taking the initial energy and subtracting it by the final kinetic energy.
3.55.
3.55 times 10 to the minus 3 joules lost to friction.
So our roller coaster apparatus successfully demonstrated the principle of conservative and non-conservative energy transfer.
Thank you.
Thank you.